So, as a general rule, never assume that you know how many bytes are required to hold a piece of data. Don't allocate memory using a simple integer such as 24, as shown here, when you're allocating a specific number of bytes. Instead, make a habit of using size of to calculate the amount of memory needed, like this. That is much, much safer. The good news is that when you do pointer arithmetic, you can let the compiler work out how many bytes it needs to move in order to go to the next element. Recall that in the earlier program that I wrote here, I did some pointer arithmetic with ints. So I've got an array of ints, and when I added 1 to the pointer variable, that caused the pointer to reference the element 4 bytes along from the previous element. And now with my struct, I have a more complex data type which can take up either 24 or 32 bytes according to how I declare its fields. This only works, by the way, with arrays of specific data types. You can't do pointer arithmetic with generic pointers, pointers to void, unless they are first cast to a known type. Pointer arithmetic with fairly complex types, such as structs, is just as simple as with simple types, such as integers. Adding 1 to the pointer variable moves it to the next element. That is the second element in my array of structs. That's a great thing about pointer arithmetic. The compiler can figure out how many bytes each element in an array occupies. When I add 1, I'm not adding a specific number, certainly not the integer value 1, to the value of the pointer. I'm telling the pointer to move 1 complete element along the array. And that is how pointer arithmetic works.